Semiconductor manufacturing is an incredibly complex process that transforms raw materials, primarily silicon, into integrated circuits (ICs) that power almost all modern electronic devices. The process can take several months and involves thousands of steps performed in highly controlled environments called cleanrooms. The process is generally broken down into two main parts. Front-end process, wafer fabrication. This is where the actual circuits are built on the silicon wafer. Back-end process, assembly and testing. This involves packaging the finished chips and preparing them for use. Front-end process, from sand to chip. Wafer preparation. The process begins with silicon, one of the most abundant elements on Earth, typically sourced from sand. The raw silicon is purified to an extremely high level, then melted and grown into a large, cylindrical crystal called an ingot. This ingot is sliced into very thin, circular discs known as wafers, which are then polished to a mirror-like finish. Oxidation and deposition. To create the different layers of the circuit, various materials are added to the wafer. A thin insulating layer of silicon dioxide, CO_2, is grown on the wafer's surface through a process called oxidation, acting as a protective barrier and an electrical insulator. Other materials, such as metals for wiring and different types of semiconductors, are deposited onto the wafer in subsequent steps. Photolithography. This is the most crucial step for creating the intricate patterns on the wafer. The wafer is coated with a light-sensitive material called photoresist. A mask, which contains the circuit design, is used to project a pattern onto the photoresist using a light source, often deep ultraviolet or extreme ultraviolet. The exposed areas of the photoresist undergo a chemical change, etching. After lithography, the parts of the wafer not protected by the hardened photoresist are etched away using chemicals or plasma. This carves the circuit paths and components into the underlying material. The remaining photoresist is then stripped away. Doping. To give the silicon its electrical properties, impurities called dopants, like boron or phosphorus, are intentionally introduced into specific regions of the wafer. This process, known as ion implantation, creates N-type excess electrons and P-type electron holes regions, which are essential for creating transistors and other components. These steps, deposition, lithography, etching, and doping, are repeated hundreds of times, adding layer upon layer to build a complex, three-dimensional circuit. Back-end process, finishing and packaging. After the circuits are built on the wafer, the front-end process is complete. The back-end process begins with wafer testing. The entire wafer is tested to identify any defective chips, dies. A probe card makes contact with the thousands of circuits on the wafer, and an automated tester runs diagnostic tests. Defective dies are marked for discard. Dicing. A precision saw with a diamond blade cuts the wafer into individual chips, or dies. Packaging and assembly. Each individual die is mounted into a protective package that provides a physical connection to a circuit board and protects the chip from the environment. Tiny wires are bonded from the die to the package's pins to create an electrical path. Final testing. The packaged chips are subjected to a final series of tests to ensure they meet all performance and quality standards before being shipped to customers. The entire process is a marvel of engineering, requiring extreme precision and a massive investment in specialized machinery and facilities.